my name is Sarah St. Jean, and my mega mission is IceSMAP. IceSMAP is a combination of Operation IceBridge and SMAP. IceBridge looks at polar ice, while SMAP measures soil moisture. IceSMAP is a 10-year-long program using a satellite platform. It holds 5 tools: radar and a radiometer, which I'll talk about in a minute, a gravimeter, which measures the pockets of water near the edge of ice, a magnetometer, which measures the magnetic properties of bedrock, and bedrock's the rock underneath ice, and a laser altimeter, which measures the changes in ice elevation. The difference between radar and a radiometer is that radar is an active tool, while a radiometer is a passive tool. A radar actively sends signals down to Earth and then listens for the reply to gather their data. And while a radiometer just listens to the signals or radio waves that Earth naturally emits. So a radiometer is like eavesdropping into a conversation, while radar is like having a conversation with somebody. IceSMAP has 4 main goals that are all to help its mission statement. Mission statement is to assist the work of climatologists, meteorologists, topographers, oceanographers, and geologists. It does this by helping with the modeling of climate change, by looking at severe weather patterns and how the ocean level is rising because of the ice melting off the poles. Learning more about the polar landscape by looking at the bedrock underneath the ice. Predicting droughts and floods by looking at the soil moisture to be able to early alert to these events. And crop yield, because some crops require a lot of water and some require little water at all. And so different regions of the earth can learn what crop will best grow in their region. The 3 science questions that IceSMAP is attempting to answer is: how is the climate changing? Climate change is a really big topic on the global stage, and IceSMAP will provide important data about how all of the things are changing. What the topography of the Arctic. The landscape or topography of the Arctic is basically unknown right now, and so they want to learn more about that to help support theories like plate tectonics. And how can we improve crop yield? Like I said earlier, some crops grow in specific regions based on the soil moisture, and there are a lot of third world countries that need more food, and so being able to tell what crops will grow best will greatly help their food supply. Now, why a satellite? Why not a rocket or a balloon? Well, sounding rockets only last about 5 seconds, and a scientific balloon will only last about 30 days. We need a long-term platform to be able to support this mission's goals. So with a satellite, it can stay up for the 10 years, and some satellites stay up longer, and every 5 days it will scan the same piece of Earth. So it takes 5 days to do a complete Earth scan. Now, the IceSMAP mission has 4 main subsystems. It has a safety system, but the safety system is basically the propulsion system. Because as a satellite platform, the only safety system it needs is to make sure it doesn't run into other satellites and break them. So, the power system that it uses is a solar-powered system. The control system it uses is it's autopilot like airplanes, and it uses a star sensor which looks at the constellations to figure out where it is and can orient itself to within 1/10 of 1 degree. It also uses a sun sensor to be able to position the solar panels to get the optimum power. It uses a propulsion system of small rocket thrusters that fire about once a month to make sure that it's staying on track and doesn't run into other rockets. So the propulsion system doubles as its safety system. And a communication system. It uses the near-Earth network to communicate with the ground. The near-Earth network is a series of ground stations that are located all over the world in places like Greenland and Alaska and Australia, and it communicates with those stations continuously to be able to continuously download to the network. This is my chart of how all the systems work together. It has two main power, which is the solar array and rocket fuel. The solar array goes into the battery, and the battery powers the control system, the communication system, and the scientific instruments. In the control system, everything gets connected into the central computer. The data collector, which is basically a hard drive or a SD card, it holds all of the data before it gets communicated to the ground. A star sensor and sun sensor both go into the autopilot system, which drives, and that all goes into the central computer. The central computer brings all of the data to the communication center. The sun sensor goes up to the solar array, and the autopilot system controls the propulsion, which is made up of small rocket thrusters, which keep it on track. Now, the battery also powers the scientific instruments. The antenna, which is this a big umbrella-like thing that gets deployed in space and spins around, is how it scans the radar and radiometer. And so that's a big part of the scientific instruments. And all of the scientific instruments have to be powered by the battery. All of them go to the data collector, which then goes to the central computer, which is communications. The communications is just a signal to the ground, which goes out to the near-Earth network. And the rocket fuel I have up here in the power is what powers the propulsion system. IceSMAP is definitely a team effort. Engineers need math to be able to calculate how fast the antenna needs to spin around and how much fuel will the mission need, etc., etc. Engineers need scientists to know what instruments will answer the science questions and what science questions the mission needs to ask and answer. Engineers need technologists to be able to put all of the instruments together and make it into one big package that will go into the space that the engineers give the technologists. And so the engineers need the technologists to make sure that all of the tools required to answer the science questions are there. That's it.